Hello, I'm Gabriel Marins. I'm an ecology master student in University of Brasília, and I'm here to present my work with fellow colleagues Rosa Cartagenes and Dr. Roberto Cavalcanti from LabBio at University of Brasília. Our work is titled Opportunities for Ecological Restoration of Exotic Grass Areas and its Potential Impact on Avian Biodiversity in Urban Conservation Units of the Cerrado. The Cerrado Biome is the most diverse tropical savanna in the world. Approximately 6% of the world's species occur within its boundaries, with a high degree of endemism. It is the second largest biome in South America after the Amazon forest and occupies 24% of Brazil's lands. Today, the Cerrado is an agricultural frontier with over 50% of its areas converted to croplands and pastures since the 1970s. In this context, urban green areas can be important repositories for the Cerrado biodiversity. And since they are close to high density urban areas, their ecosystem services provided can be of extreme importance to the population around them. But today, urban green areas within the Cerrado are suffering from the exotic grasses invasion, sometimes introduced intentionally for aesthetic purposes, but sometimes also unintentionally dispersed. These exotic grasses reduced native habitats, causing loss of foraging niches and local extinctions of different taxa, with one of them the birds. So within Brasilia, we have different styles of urban park. Some have large exotic grass areas with a few planted trees, and some have a quite significant area of conserved native vegetation with few exotic grass areas. So our objective here was to evaluate the importance of native vegetation in urban parks for the maintenance of bird species richness through species area relations, and also to assess the potential increase in bird species richness if exotic grass areas of this park were to be restored with native vegetation. For that, we used data from 9 urban conservation units from Brasília, Brazil. So most of the conservation units we chose were within the Brasília urban core, but 2 of them were in metropolitan regions, also urban areas. So we collected land cover data from these conservation units from MapBiomas platform, which provides us with land cover data from all of Brazil, and it is sustained by governmental institutions, NGOs, and research institutions. We use QGIS software and Lycos plugin to extract the percentages of vegetation cover within each of our urban conservation units. We use biodiversity data from citizen science platforms like eBird and iNaturalist, summed with species lists collected in the conservation units management plans, which is standard the collection of bird species for the realization of these management plans. So we used native vegetation cover area to calculate the species area relation with a semi-log model, like suggested in Wilson and collaborators 2020. So the X label, the native area was log transformed, while in the Y label, the species richness was untransformed. So we expect a curve with a high rate of species richness gain within a few small areas, and a asymptote reach when native area gets bigger and bigger. So our conservation units comprises parks with over 70% of exotic grass cover, and parks with grass cover below 20%, and with native vegetation cover of over 70% as well. So we realized that the total native cover within these 9 parks was 115 hectares, averaging close to 12 hectares per park. And we also noticed that exotic grass areas comprised a way larger area of 413 hectares, with 45 hectares per parks as an average. So our model explained 44% of species richness variation, and we calculated through it that ecological restoration in exotic grass areas would generate an average increase of 51 bird species per park. So we used the native vegetation cover relation with bird species richness and calculated how much species richness would rise if we restored the exotic grass areas from these parks. And we noticed that the increase in richness is much more significant in small conservation units, since they have less native cover and less average species richness. So the introduction of exotic grasses compromises the survival and the persistence of typical endemic flora and native flora, which are extremely associated with avifauna through specific foraging niches, like exemplified on Marini 2001 on his work about the effects of forest fragmentation on birds in the Cerrado region. Like, we see that the larger the native forest area, the largest the proportion of forest dependent birds, or we could call them forest specialist species. So we noticed that these birds are really depending on their specific foraging niches, which have been lost because of the invasion of exotic grasses. We also realized that these exotic grass areas can be causing a loss of ecosystem services provided by these birds. We see in nature, in native areas, that native bird species provide a series of ecosystem services, like the seed dispersal, that can be highly affected by human populations, which are related with high populations of exotic birds which compete with these species, and also increases the rate of these services related to birds, like the dispersal of diseases through pigeons, or the compete for resource through the passer birds. So we notice in Cox and collaborators that the highest the human populations, the smallest is the rate of service to the service of birds. So we suggest that these urban areas management need to include the control of the exotic grasses, mainly with restoration of native vegetation to recover bird species richness, which can be attracted to these areas by this native vegetation and dispersed to these areas by flying. So birds are interested for this purpose. We conclude that ecological restoration of exotic grasses area is an opportunity to promote the expansion of the Cerrado biodiversity within urban areas through the interaction of these avifauna and the endemic flora of this biome. We also conclude that urban conservation units restoration efforts will have a significant impact on bird species richness, especially on small conservation units, small parks through the increase of bird species richness in parks with low richness, and we think the restoration of these areas can contribute to the conservation of Brazilian ecosystems. Here are our references and image links, and we thank the University of Brasília, the LabVIEW Laboratory, MapBiomas, R programming software, QGIS software, and IBRAM, the Environmental Institution of Brasília, and the ATBC for the opportunity to present our work. This is our team, and thank you.